All right, so we're going to check out the other two sets of bugs, B and C, and then A and C, to see if either of those sets collide. We'll take a look at bug B and bug C as our next ones. So again, I'm just solving each of the equations, putting it in rectangular format. So we already kind of saw from graphing this, if we set these equal to each other, we're going to end up getting 0 because they seem to have the same starting point. Whoops. Minor blunder, we just had a little t here instead of an x, sorry about that. So 5 over 3x equals 4 over 3x. You're going to get 1/3 x is 0. And if we keep going through with the solving of this, if x is 0 and y is 0, then t is also 0. What does that really tell us? Are they colliding? Not really. They're actually starting at the same point. All right, so we have our last one. Hopefully this one will show us a collision at this point. Bug A and bug C. Now I already know rectangular equations for each of them, so I'm not going to redo that process again. And you can go back and flip over to the front to see that that's the equation we got for bug A. Bug C we just did. We'll plug in just like we did before. So if you want to try some of the calculations for these, you definitely can do that. I'll just show you what it comes out to be when you do the calculation. And then if you combine it, do your flipping and square rooting, you're going to get x is about 3.395. Again, plug that into the easier equation. So 4/3 times the 3.395 would give you about 4.53. And the best thing to do with these is to keep using your calculator answer if you're not getting exact value answers. And some of the intersections you will get exact answers. All right, so again for bug A, and then also for bug C, we're plugging that in. You have to kind of go back to the front. We had done x over 3 is equal to t. Now, if you've gone back and used rounded values, it may not come out perfectly, but this is fairly close, especially with rounding, that it looks like they do collide. And even if there's like one's a little bit closer than the other at that time, the size of the bug, probably at some point on them, they are going to collide. So the way you would write this, bug A and C collide at that point. And then you also want to say at the 1.13 seconds because the time is important. Otherwise, they would not be colliding. All right, so that's it for the intro notes. We're looking more at the projectile motion like we just did in the previous lesson with the bugs going in those different directions. You are going to go back and do some other equations to see if the equations collide. That might be a little simpler, maybe a quadratic and a line or all lines to kind of see how this works. So you may get a little bit more exact answers when you're doing the practice on your own.